Welcome to TechTalks.com. In this video, we are going to look at our new chapter, that is the third chapter under statistics and probability. And the chapter is called scatter diagrams and correlations. So in today's video, we are going to look at scatter diagrams and correlations. But before even we proceed, we can look at what we are calling scatter diagrams. Sometimes you can call them scatter graphs. It will still be the same thing. So scatter diagrams or scatter graphs, these are graphs that shows relationship between two variables. So it's defined by definition. Scatter diagrams are graphs that shows relationship, or you can call it correlations. Relationship is the same as correlation between two variables. So these are our scatter diagrams. We say the scatter diagrams are graphs that shows relationship between two variables. Basically, there are two variables. If you have maybe variable x and variable y, so having different points under variable x and different points under variable y, you combine those points, and then when you plot them, you obtain what we call scatter diagram. So we have said there it shows relationship. So what are those relationships? Shall go straight to the types of relationship or correlations under scatter diagrams. Correlation and a scatter diagram. The first one, we have what we call positive correlation, or you can call it positive relationship. So positive relationship, this occur when two variables, both of them are having values that are increasing, or both variables are increasing or decreasing. That one you obtain what we call positive relationship or positive correlation. I've said this occur when both variables let me say variable x and variable y when both variable y and x increases. So you obtain a relationship which is a positive one. When both of them are increasing, you obtain relationship which is positive. Taking example of how you plot it, if this one is our axis and we are plotting a scatter diagram or a scatter graph, you said if you have variables x and y will go in its axis and x will go in its axis. and then if both of them are increasing, implying that they will have data points that is increasing throughout. That if this one is a point of x, so another point will obviously be when x has increased and y has increased. So you see such points when generally both of them are increasing, we obtain what we call a positive relationship or a positive correlation. And when you pass a straight line through these points, or that is the line we call line of best fit through this point, such that this point or this line you take, it must divide these points into two equal parts. That if 9 are remaining downward and 9 should be upward. Now, for example, here we are taking a point or a line that is dividing 4 points downward and 4 points upwards, but taking note that this straight line is going through 2 points. So here we just take a line of best fit, but we don't depend on the number of points which it is going through, but so long as it can divide them into 2 equal parts, because these points are scattered are not necessarily in the straight line. If you find them in the straight line, then that one is well and good. So as you can see that these points are close to this straight line. This line you must use a ruler to draw this line of best fit. For me, I've used freehand because I don't have a ruler. So these points are close to this straight line that you are seeing. Straight line, this one, but this straight line has a positive gradient, and a positive gradient. So this one make it to become a positive relationship or positive correlation. Then we have the second part, or the second one, part B is negative correlation or relationship. So negative correlation or relationship, this occur when one variable is increasing and the other variable is reducing. When you plot such points, you come out with a relationship which is called negative relationship. So if you have your points, or if you want, just take note that you can say this occur when one variable increases and the other variable reduces or decreases. You can use the word decreases, and the other variable decreases. So that one brings us to the negative relationship or negative correlation. So if you have your point and this is your point, you find that in this point, if you start here by point which is plotting y against x as our variable, then at this point y is bigger than x. So you find that another point is maybe at this end, where you find that y has reduced and x has increased. So this one show you that in those variables, one of them is increasing and one of them is reducing. So if you finish plotting all the points, you find out that this relationship is taking this pattern. It's taking the pattern that one of the variable is reducing and one of the variable is increasing. So as you see this one, the points are close to the line, and this line, when you get its gradient, it has negative gradient. So if you take the note of this, that these points are close, these points are close to a straight line that, or which has the negative gradient. So from negative gradient, that one make our relationship to become negative relationship or negative correlation. That's how it happens for the negative correlation. And then we have another one which is called the another relationship which is called negative, part C is called zero relationship, or correlation, and also you can call it no relationship. No relationship or no correlation. So that one is our relationship or another relationship. So if you find that when you have drawn your scatter diagram of variables y and x, you have points of this nature. After you obtaining your points, it form a figure which you can see it as a square. So it is difficult here to determine where the line of best fit will run, or where the line of best fit will be. Otherwise, someone may choose to use this one as the line of best fit. If you use this one as the line of best fit, it's true it's the line of best fit. We have left 1, 2, 3, and then here also it is having 1, 2, 3, and it is going through 3 points, and it is going through 3 points. So someone can use this and still is the same thing. Someone can use this one and someone can use this. So it will bring confusion, which is difficult to identify which one will be the line of best fit. So for that reason, this one, it has, or it become, or it records what we call zero relationship, because it is difficult for you to identify where the relationship will lie, because it is also difficult to identify which line will occur. Because for someone who will use this one, a straight line which is horizontal through these points, what is that relationship? Is it positive or negative? If you use the vertical one, is it positive or negative? So it will become difficult for you to understand the relationship. So that's how this one are classified in those 3 main relationship. And then there is another relationship, which is the last one, is called perfect relationship. Perfect relationship. Let us look at that relationship, which is the last but not on the list, but you can know it. Part D, we have a relationship which we are calling perfect relationship or correlation. or correlation. So this perfect relationship occur when all the data points of your two variables are in a straight line, or when all of them, that line of best fit is passing through all of them. That's when you find that you have obtained what we are calling a perfect relationship or a perfect correlation. So if, take example, if you have your data points that are plotted and they are giving you this one of y and x, and they are giving you a relationship of this type. So you find that all the data points are on that line. So this one, then obviously it will become a perfect relationship. But in which direction? This line is having positive gradient. So this one will become a perfect positive correlation or relationship. A perfect positive correlation or relationship. Then you may find that in another data set of those two variables, you find that your relationship is given in this way. This one variable y and variable x. So you find that relationship are along the straight line but with negative gradient. So this relationship is also a perfect relationship but with the negative gradient, which qualifies to be our negative. It qualifies to be perfect negative